So if you're a software developer, you probably heard the word IDE, which isn't a word, it's more of an acronym, which stands for Integrated Development Environment. But really, what is an IDE, and what are the differences between IDEs like Visual Studio and JetBrains, and code editors like VS Code, Zed, Vim, and Emacs. So an IDE is something that has most of the features that you can expect from a full development environment. So it has a debugger, obviously a code editor, and oftentimes it has profiling utilities to check out hotspots in code and something like that. The first two are mandatory for an IDE. The debugger and code editor are really, really important, because if you're editing your code, you need to see where it's going wrong, if something goes wrong. And then there's the case where you don't know that something is going wrong, so you have to step into the functions and see where the bug is happening. Code editors, on the other hand, are more dependent on plugins, meaning that they just offer the editor part, and they rely on things like language server protocols or LSPs, or something like LLDB for debugging. They rely on all of this stuff to provide a similar experience to one of an IDE, but obviously they're much different to set up and stuff. There is a problem with most IDEs, actually with all of them, which is they have a bunch of features, but they are super slow, meaning they take a long time to launch, they take a long time to debug. Oftentimes stepping through the code causes bugs of all sorts, meaning like for example the watch window, which I'm gonna show you later, doesn't get updated in time, so you have to rerun the program again and things like that. But the most important one for me is speed. IDEs are slow, really slow, and partly because of years of tech debt and years of bad coding practices that reached a level where they're basically impossible to go back from, and to go back to a working state. Visual Studio is a mess. It's like the most bloated software ever created. It's incredibly broken, incredibly buggy, incredibly slow, and so on. I think we can do better than that. I really believe that, and so I created Icarus. It took me a lot of time. I started the project in early 2024, and I worked on it ever since, almost every day, and I'm finally ready to do a complete showcase of the features, and yeah. So here it is. This is a shortcut, obviously it's not the program, but if I open the shortcut, you can see it right here, and it's I don't know if you read that, but it's a 2.5 megabytes executable. For reference, Visual Studio, this is how much Visual Studio, how much space Visual Studio takes. 5 gigabytes on just the C++ install that I have. Icarus is several orders of magnitude smaller than that, and it's a single executable, meaning you can launch it from anywhere. You can have it on a pen drive, you can have it wherever you want. You just launch it and you start programming. So let me start it up and show you the features. Here we start to see the new interface, because in the previous videos I have shown some stuff, but I haven't really shown what I was working on for real, which is a completely new hardware based renderer for Icarus. This renderer allows for really fast hardware based rendering, obviously, and everything is now much snappier, much faster. And you can see I've also introduced a lot of effects, like for example the menus are all animated, they have shadows. I can toggle the file browser and it pops up like really nice. But that's just visual things. It's not really doesn't really change the experience that much. I mean, it surely does improve the visual look, but I want to focus on features. So let's create a new project, because obviously we can do all of the normal stuff. We can create a new file, we can save files, we can open files, we have custom dialogues for files, we can open folders, and it will automatically detect if a folder contains code, C or C++ code, and it will ask you to create a project. But we want to create a project manually. So let's go to a new project. It will pop out this window, and we can see a bunch of templates. There's a console application, a Windows application, a DLL, a static library, a header only library, and a TCC application. The last one is just an application which uses the integrated compiler, because Icarus has an integrated build of TCC, the Tiny C compiler, meaning you can build applications and software without even needing a compiler. And that is all bundled in the 2.5 megabytes, by the way. So let's start with a console application. Let's go to next, and it will ask you for some stuff. First of all, a project name, we're gonna call it whatever. Then a project location, I'm gonna put it here in my Icarus projects folder, whatever. Then it will ask you for a compiler. And obviously here you can choose GCC, you can choose Clang, or you can choose MSPC. I personally use MSPC. I have it on the path variable, meaning you can access it from anywhere. So I'm gonna use CL. And the language standard, so C99, C11, C17, C23, or latest, which is always the latest standard. But I'm gonna go with C99, which is what I use always. So now we can create the project, and you can see it set up a folder, it set up some files. So if I go in Show in Explorer, you can see it created some files, a .trprj file, 2 scripts, an src folder with a main.c file, and a bin folder for the executable. So if I want to change any kind of settings for the project, I go into Project and go Project Settings. And here you can see we have a bunch more settings. We have the build configuration, if I want debug or release, the target platforms, x86 for 32-bit application, or ARM or x64, a custom platform name, the compiler backend, the references to other trprj files, but I'm not gonna show this in this video, and other build targets and the target index. So I'm gonna change the author of the project to Giovanni, just for example, and I'm gonna save. Oh, and also a very important one, the debug arguments. Here you can tell the debugger something to run. So for example, if you're writing a file compressor, you can type here the arguments, and when you run in debug mode, it's gonna run with those arguments. Really simple. So let's save, and now let's write some code. Here we are including stdio, so meaning we have access to the standard library functions. You can see the little cursor being animated as we move. I really like how it works, but if you don't, you can just disable it here. It's in view smear correct. If you disable it, it's gonna act normally, but I'm gonna leave it enabled because I really like it. Now let's do something very simple. Let's have a struct, and you can see as we type, we have suggestions coming in from the integrated C parser. You can also see if I type like brackets, I get put automatically inside of the brackets, which is very, very nice. And if I move at the beginning of or the end of a bracket, I automatically highlight both brackets. This is very useful when you are in deep nested code and so on. So we're gonna have a struct called vector2, for example, and we're gonna have an int x and y. Very simple thing. And here you can start to see how nice Icarus is, because here we have a pop-up that says the size of the struct. So I'm gonna temporarily disable it, just because it is a bunch of it's kind of too much to see for me, but it's just personal preference. So I have done something a little bit more complex here. I've well, complex, it's not really complex, but it's just to show the power of Icarus. I have to include stdlib because I'm using malloc. And you can also see I have all the headers. The IntelliSense works with headers as well. So I'm allocating into the heap a vector2. So it's gonna allocate space for two integers, x and y. If I type vec2 and I type the arrow, I get the two members. So if I want to set x to something like 3 and y to something like 255, I can do that. And if we build, I'm sorry. Here's another thing. We have inline errors. You can disable those, and also clicking on the error in the console will bring you to the line of the error. In this case, the error is a syntax error. It's missing a semicolon before the integer type. So I'm gonna add it, and this wasn't intentional, by the way. So it built, and now I can run it, and you can see I have my vector2 printed out in the console. So this is pretty simple stuff, but let's say we want to see where in memory is it being allocated. Now I could print the location of the address in memory, but let's say we want to do it in a cooler way. I can add a breakpoint pressing F9 on the line, or you can click on this little section here and it will add breakpoints, and I can start debugging. and here it will expose a bunch of views which I'm not gonna all enable now. I'm gonna enable them progressively. If I type vec2 here, the first one is the watch window, which is something like Visual Studio's watch window. We have a little pop-up here which says that the vector2 is null because it's not initialized. But if we step after the line, because remember the debugger stops before the line executes, we can see the address in memory, and we can see the two variables which are not yet initialized because we haven't assigned anything to them yet. So we have just discovered, for example, this is obviously a stupid bug, but we have discovered a bug. Another thing we can do is in the debugger view is check the address of stuff just by hovering over it. So if I want to check, for example, if the vector2 is initialized, I can just hover over it. I want to check the address of malloc in the binary, I can just hover over it. This is really nice if you're debugging very complex applications. Now we have a memory view in which you can type address of bytes to do search. I can just type ff, and it will show me all the locations in which this thing is shown. I can scroll down and I can click on each one of them. It will bring me to a different memory section. It's really nice if you're working on reverse engineering or something like that. Then we have the registers view. It just shows the registers. If it was a 32-bit application, obviously the registers would be EAX, EBX, ECX, and so on. I can also use the disassembly, obviously, because we are programmers, we like assembly. So I can see the actual instructions that are being executed. The call stack, which is very useful in the case of a crash. So if I, for example, free the vector2 here, and then I try to access vec2.y equals 4, for example, I can start debugging, and if I hit continue, I will have an access violation, and the call stack will see exactly where it happened. It will stop there. I can continue and it will crash, obviously. We have the local variables, which is a view exactly like the watch view, but it takes the locals, so the ones that are in the current scope. Finally, we have the profiler view, which is just a thing that shows the thread registers. It shows the threads spawned by the operating system, the memory that's being used, the CPU usage, and so on. Obviously, you can step over, step into, and step out of functions. You also have the option to attach to existing processes. So if you want to use the debugger, you can use the debugger not only to debug your own processes, but to debug other stuff. We have themes. So we have, for example, the light theme. I'm sorry for burning your eyes. The Monokai theme, the Groovebox Dark theme, for example, one of my favorites, but I'm always going back to the default one. We have the finding files, which is just a view that shows stuff. It's really useful for looking up things really quickly. And it's fast on even project with millions of lines. There's also the auto formatter. So for example, if this document wasn't formatted for some reason, we could press edit, format document, and it will auto format it. This will work even for really nested stuff. So if I had a document like this, I could just press format document and it will auto format it. Really useful for certain use cases. And yeah, I guess that's it. This was a really brief showcase. You also have the ability to put the window in full screen if you're used to this. And now I want to talk about a couple of things. I'm working on a Linux and Mac OS port. it will take some time because a lot of Icarus is platform specific, but I'm especially like the debugger part is very platform specific. I plan to have Linux and macOS port complete by the end of the year, with debugging abilities and so on. And I also want to talk about the excuse parade. The excuse parade is a term that I think Casey Muratori invented for his ref term video. Basically, a lot of people think that Visual Studio, for example, is really slow because it has a lot of features. And if you somehow manage to create all of the features that Visual Studio has inside Icarus, for example, Icarus would become as slow as Visual Studio. It's definitely not the case. That's not how software works. It's just a series of bad coding and programming practices that made the program basically unusable. So yeah, I guess that was my my take on software. This is my product. I hope you like it. There's a link in the description. It's on sale until Monday at $20, €20 actually. And yeah, let me know if you like it.